Hi everyone, I hope you all are doing well and good, right? So in today's class, we will be discussing the further most important topic of trigonometry, that is a part like trigonometric functions, and we will be discussing about the trigonometric angles of any size. So here we will just have a proper like you can say small scale of record from the previous chapter, that is part one of trigonometry, and after that we will be solving the question based on that concepts, as well as we will be discussing the trigonometric angles for any size. Okay, so let's start today's class with the topic that is trigonometric functions. So before that, let's have a recap for the previous class. So here, if I have told you that all about the trigonometric ratios, right? So how many trigonometric ratios we have discussed? So in that, we have discussed all about the 6 trigonometric ratios. The first one was sine, the second was cos, the third one was tan, whereas the next one is sec, cosec, and cot. So these were the 6 trigonometric ratios that we have discussed, right? These were all the 6 trigonometric ratios that we have discussed, right? Okay. So now let us move further and discuss the question based on this concept. Before that, I would like to introduce the small concept all about trigonometric functions. So let's have a discussion based on this. Trigonometric function. What are trigonometric functions? Let's have a discussion based on that. And we will be just saying that what are the trigonometric functions for all the angles of any size, right? So as we have discussed all the trigonometric ratio now, like sine, cos, tan, sec, cosec, and then cot, right? So if we just move further, and we can see that, let us consider a right angle triangle. Before that, I would like to have a circle part so that we have a proper clarity and understand the concept, how it has been came in the part. So let's draw a circle first. Let's suppose this is our circle. Now let's have the axis over here to understand the concept. Okay. Now let us move further. Now here you can see that the intersection point is set to be as what? It is set to be as O. That is your origin, right? And as we all know that here we will have a construction like this is a point, and here we will draw a right angle triangle. Okay. So let's suppose this is the point we are having. It is a name as P, and it is having a coordinate that is x comma y, where x is absolute and y is ordinate. Together it is said to be as coordinate, and which is right angle at here, right? So distance from, like if you name this as O A P, so distance from OA is x, whereas the distance from P to A is y, and the distance from O to P is L, right? So if I just say that, of we have the triangle taken out from this, so it will be more clarity for this concept. Now, if we just see here, we are having a 90-degree, right? And this is O, A, P. As I have told you, this is what, as we have considered this as a Y, and this is as X, and this is as a L, right? So if we just see that, as I have told you all about the trigonometric ratios, that is sine theta is equal to perpendicular upon hypotenuse. So here if we just see that, let us take this as a reference angle, that is theta. So here the sine theta will be perpendicular upon hypotenuse. If we just substitute the value, it will be what? It will be y upon what? Let us take it as 1 first. That will be more feasible for us. Okay. So it is 1 unit. So here we have got, that is sine theta is equals to y upon 1. If we just do the further summation, so it will be, that is sine theta is equals to y. So let us have equation number first, right? Okay, now let's do the same for further trigonometric ratios. If we just see for cos theta is equals to what? That is base upon hypotenuse, right? So here if you just see the base is x and hypotenuse is 1. If we just further solve it, it will be also, that is cos theta is equals to x. And let's name it as equation number 2, right? And now let's have the same trigonometric formation for tan theta as well. So tan theta is what? That is perpendicular upon hypotenuse. No, it is perpendicular upon base. So if we just see that, it is y upon x. And we just furthermost, we can say that tan theta is equals to y upon x. And let us name this as equation of 3, right? And if you see here, so if you see here, that is tan theta. What was y? From equation number 1, we can say that this is sin theta. And from equation number 2, the value of x is cos theta. So from here, we have just got the relation between tan theta, that is tan theta is equals to sin theta upon cos theta. So here, from here, we have got the relation, that is tan theta is equals to sin theta upon cos theta. As I have told you, the inverse of that, right, or reciprocal, we can say that cosec is the reciprocal. Cosec theta, we can say that is 1 upon sin theta, right? As we can see that is sec theta is a reciprocal of cos theta. And whereas we can say that tan theta is a reciprocal of 1 upon cot theta. So these were the trigonometric ratio formulas that we have discussed till now. Okay, now let's have some question based on this concept. And after that, we will be discussing all about the trigonometric function with the different type of angles, right? Okay, then. Now let's start the question based on this concept so that we get a clarity what we have studied and what other things that we are not clear enough, right? So now let's start with the first question. If I say that, first question is that if we have been given sine A is equals to 3 by 4. And here we need to just calculate, that is cos A and tan A, right? So we will start solving this question. So first of all, we need to just identify what are the things being given. So here we are having that is sine A is equals to 3 by 4. As we have learned the concept, what is sine A? Here we are talking about the reference angle. This is basically your reference angle that we are seeing, right? And it is having the value that is 3 by 4. What does it mean? It means that if you know the trigonometric ratio for sine, that is sine angle A, that is 3 by 4. And we know that sine theta, what is the formula? That is perpendicular upon hypotenuse. So here we are having this value of perpendicular, that is 3. And here we are having the hypotenuse value as 4. So now, if we have solved this further, we need to just construct a right angle triangle. So just find each and everything in formation, right? Okay. So now if we just see here, we have drawn a right angle triangle. Let us name as EQR, where it is 90 degree at Q, right? Can we take this? No. Why? Because the reference angle is A. So we need the same values over here, right? So if we see here, it will be A, B, and C. So the reference angle that we are going to take is angle number A, that is theta, right? Let's suppose it's a theta, or you can just take angle A as well, right? Now, if we see that, I have told you this is opposite, it will be perpendicular. This will be base, and we know that 90 degree opposite what? It is hypotenuse, right? So by Pythagoras theorem, we can just calculate each and every values. So here you can see that we have been given the value that is perpendicular as 3. We are having the perpendicular as 3, right? And base is there? No. We are just having the hypotenuse, that is 4, right? We need to just calculate the base. So by Pythagoras theorem, we will be solving this. So by using Pythagoras theorem, property or theorem, you can say. So from here, we know the relation, that is hypotenuse square is equals to perpendicular square plus base square. If we just move further, so we can say that what is the value of hypotenuse? That is AC square. What is perpendicular? That is BC square. And what is base? That is AB square. And here we need to just calculate here, that is base, that is AB, right? So we will just shift it. So it will become AC square minus, at positive will move there. For transposition, the positive becomes negative. So it will be AC square minus BC square is equals to AB square. If we just solve it further, what are the things that we will be getting? So if we just substitute the value of AC is what? It is 4. What is the value of BC? That is 3. And what is the value of AB? That we do not have, right? So if we just move further, here you can see that what? That 4 square is 16 and 9 square is, sorry, 3 square is 9. So if we just do the subtraction part, 16 minus 9 is what? Just calculate it. That is 7, right? That is AB square. If we just solve it further, it will become AB. Now, square will be shifted there and you will be getting the value as AB is equals to under root 7 unit, right? So we have just got our base value as under root 7, right? Now, what are the things that we have to find? So we need to just find a trigonometric ratio, that is cos A. Now, what is the formula? That is base upon hypotenuse. What was base? That was root 7 and hypotenuse was, it was like what? It is 4. So we have got the value for the trigonometric ratio, that is cos A. Now, if I just want to know for the tan A, so what's the formula? That is perpendicular upon base. What was the perpendicular? So we have got the base as root 7 and perpendicular was 3. So the trigonometric ratio that we have got for tan is 3 upon root 7. Can we leave it like this? We have to just rationalize it. That will be more better. So root 7, it will be rationalized, right? So here we will be getting 3 root 7 upon 7 units. I hope it is very clear to each and everyone. So here our first question ends. Now let us move to solve some more typical type of questions for this concept, right? Okay, so let's start with that. Okay, so now let us move to solve the second question. So the question says that is 15 cot A is equals to 8. Here we need to just find that is sine A. And the second that we have to find, that is sec A. Right? So what we need to just do, we need to just find what are the things that are being given over here. So here you can see that we have been provided with that is 15 cot A is equals to 8. What does this mean? So here, if 15 is multiplied, you can see here 15 is multiplied with the given ratio of angle, right? So if multiplication is there, we need to just shift, and multiplication will shift or transpose to there, it will become in division. So here it will be cot A is equals to 8 upon 50. And we have learned the trigonometric formation of cot A. That is, cot A is equals to what? It is base upon perpendicular. So the value of base is 8 and perpendicular is 50. So now we will just calculate for sine and sec. There we need the hypotenuse, right? In both of the trigonometric ratio, we need to just calculate for hypotenuse. So what we will do? We will just construct a right angle triangle because we need to just calculate the hypotenuse part, right? So if we just see over here, we are having a reference angle in this. What is the reference angle? That is angle A. So let's suppose this is angle A and the triangle is right angle at B and we are having another angle that is C. Now let us just substitute the value. So here we are having base as 8. As you know that this will become the base because this is adjacent side. This is opposite side, so it will become perpendicular, right? And this is opposite to 90 degrees, so it will be hypotenuse. This will be hypotenuse, right? Or in short, we can just represent it as that is H. This is perpendicular P, and this is base B, right? Now, here you can see that we are having base as 8, perpendicular as a 50. So now we need to just calculate hypotenuse. So for what we need to do? For that, we have to apply Pythagoras theorem. So by using Pythagoras theorem, so we will be getting like, if we just apply in triangle, so the hypotenuse, the value is like hypotenuse square is equals to perpendicular square plus base square, right? So if we just move further, what is hypotenuse over here? That is AC square. Perpendicular is BC square and base is AB square, right? Now we need to just substitute the value in this given equation. If we just substitute the value of AC we need to just calculate, that is hypotenuse. BC we are having a value that is 15 square and AB we are having value as 8 square. Now, if we just solve it further, we can get that is AC square. 15 square is 225, whereas 8 square is 64. So if I just move it further and solve the question, so we will be getting like that is AC whole square is equals to 225 plus 64. So if we just solve it, we will be getting like AC whole square is equals to 289. And now if we just see that this square will be shifted and it will become root under root 289. So what is the under root value of 289? That is 17. So we have got the value as 17 unit. It is basically 70 unit, right? So as this was our triangle, it was 8, it was 15, and we have got it as 70, right? So now what are the things that we need to just calculate, or the trigonometric ratio we have to calculate? So the trigonometric that shows that we need to just calculate was, that is sine A, right? So sine A is what? That is perpendicular upon hypotenuse. We will write it fully, right? Okay. So what is the perpendicular over here? Because this was our angle A. So the perpendicular is 15 and hypotenuse is 17. And what is the second trigonometric ratio? That is sec A. It is inverse or reciprocal of cos. It will become hypotenuse upon base. So hypotenuse is 17 and base is 8. So these are the two values of trigonometric ratio that we need to just calculate for the given question. I hope it is now very clear how we can solve the question based on trigonometric ratios, right? Now, let us take one more example that is of different kind, right? Third type we can see and solve, understand the concept in this as well. So here we have been given with, like given we are having, that is sec theta is equals to 13 upon 12, right? And here we need to just find all the trigonometric ratios. Here we need to just find all the trigonometric ratios. As you do more questions, you will be having a proper concept clarity how we need to just calculate each and everything, right? So here we have been given with sec theta is equals to 13 upon 12. So now what we will be doing? So let us suppose we are having a solution of here like is, we have been given that is sec theta is equals to 13 upon 12. We are having a reference angle as theta, right? This is an angle that we can see and this is theta. It is pronounced as theta. And let us assume that this is a reference angle that we provide. Reference angle, right? Okay. Now, and we need to just calculate all the trigonometric ratios. So for that, we have to remember what are the trigonometric ratios we need to just have. That is sine, cos, tan, right? There is cosec, sec is being given and we need to just calculate for cot. So these all 5 trigonometric ratios be to be calculated. So for that, what we need to do? We need to just construct a right angle triangle with proper formation, because this is the most important thing. If you just do mistake in this, it is very harmful, you can say. Your calculation will become wrong. So I have just taken the right angle over here. Now let us name this triangle. Let us say P, Q, R, right? And let us say these are the reference angle, that is theta. As I told you, this is your opposite side, right? This is your opposite side. So it will become what? It will become perpendicular. And as you can see that this is your adjacent side. This is your adjacent side. Adjacent side. So this will become base. And this side is just opposite to 90 degrees. It will become hypotenuse. So we can write it as H, right? Okay. Now, let us substitute the value. So what is the sec theta? Here we know that sec theta is inverse, or you can say reciprocal of cos. So it will become hypotenuse upon base, right? Because cos theta is what? Cos theta is base upon hypotenuse. So the reciprocal of that will be this. So here we are having as 13 as a hypotenuse, base as a 12. So here we need to just calculate the perpendicular part. So if we want to just calculate any of the like hypotenuse, perpendicular, base, so what we need to do? We need to just apply for Pythagoras theorem by using Pythagoras theorem, right? Okay. So if we just see here, we will just substitute the values in this. So it will become, that is hypotenuse square is equals to perpendicular square plus base square. This is the formula. Now we will just put the values over here. What is the hypotenuse that we are having? That is PR. What is perpendicular we are having? That is QR. And what is base? That is PQ. Right? Now we will just substitute the values in this. Right? So what is the value of PR? That we are having as 13 square. What is the value of QR? That we need to just calculate. Right? And what is the value of base? That's PQ. That is 12. Right? Now, let us just shift each and everything because we need to just calculate for QR. So if I say that here it is 13 square minus 12 square, because positive will be transport, it will become negative. So here it will be QR square, right? So 13 square is what? That is 169. 12 square is 144. And it will be QR square. If you just do the subtraction of this, you will be getting that is this. That will be 25. That is equals to QR square. And we know that whenever the square is shifted to the next or transpose, it becomes root. So it will be 25. And what is the root of 25? It is basically 5 unit. Always remember to write the unit. If meter, centimeter is there, then it's good. If it is not there, you need to just substitute the formation of unit as unit. That's the most important thing. Otherwise, your half 1 marks will be deducted from it. Right? Now, so here we have just got our base as the base is what? The base we have got it as, are we calculating for base? No, we have calculated the perpendicular. So the base we are having, and let's substitute each and everything. So base we are having 12, hypotenuse it was 13, and perpendicular that we have got that is 5. Now, what we need to just calculate? Here we will be just calculating all other 5 trigonometric ratios. So let's start with sine. As we have taken the angle as theta, so sine theta is what? Perpendicular upon hypotenuse. What is perpendicular? 5. What is hypotenuse? It is 30. What is the second thing? That is second trigonometric ratio is cos theta. That is base upon hypotenuse, the reciprocal of sec. So here base is what? It is 12. And hypotenuse is what? 13. That has been right. Okay. Now the third one is tan theta. What is that? That is perpendicular upon base. So what is perpendicular? Perpendicular is 5, base is 12. So we have just calculated all 3 trigonometric ratios, right? Now, let us solve some more, like 2 more are left, right? Okay. So it will be like cosec. Cosec theta is the reciprocal of sine. So it will become hypotenuse upon perpendicular. And what is hypotenuse over here? That is 13. And what is perpendicular? That is 5, right? Now, let us move further. And cos we have been just derived because of sec. Now we will be just taking the last, that is cot theta is reciprocal of tan. It will be based upon perpendicular. What is base? That is 12. And what is perpendicular? That is 5. So now we have calculated all other 5 trigonometric ratios. Now I hope it is very clear how we can just solve the type 3 question. If one trigonometric ratio is given and we need to just calculate all other 5 trigonometric ratios, right? Okay, now. So let us take one more different type of question, that is type 4 question. Now we will be having a type 4 question over here. So let's discuss the type 4 question based on this concept, right? Okay, so the question says that if cot theta is equals to 7 upon 8, evaluate. We need to evaluate. 2 questions are there. The first question is 1 plus sine theta, bracket close, 1 minus sine theta by 1 plus cos theta, 1 minus cos theta. And second question we are having, that is cot square theta, right? Okay, so let us see what are the things that been given. So here it is said that cot theta is given. Cot theta is 7 upon 8. So here we are having our reference angle, that is theta, right? This is our reference angle that is being provided to us. The reference angle. Now, what is the thing that we need to just do now? We will just see, as we know that the trigonometric ratio for cot theta is what? It is base upon perpendicular. So first of all thing, we will just draw a right angle triangle. So first of all, we will just draw a right angle triangle first, right? That will be more good for us. Just calculate each and everything. So let us draw a right angle triangle, and we are having a reference angle as theta, right? So let us suppose it as M and O. So the triangle we are having M and O, which is right angle at N, and we are having a reference angle theta at M. As you can see that this is opposite side. This is your opposite side. So always we know that the opposite side is what? It is perpendicular, presented by P. Now, here you can see that this is your adjacent side. This is your adjacent side. Adjacent side is just near to you or having a common vertex, right? We have studied the concept of adjacent angle where we having common arm and common vertex. So it will be adjacent side. So it is basically base. And if we see here, this will be opposite of 90 degree, it will be your hypotenuse. It will be your hypotenuse, right? That is represented by H. Now, if I just say that we are having the value of base as 7, we are having a perpendicular value as 8. So what is being to be calculated? Here we need to just calculate the hypotenuse part, right? So how we will be doing that? By just using Pythagoras theorem. By using Pythagoras theorem, or you can just say the property, right? Now, let us see that by using the identity. So here you can see that the identity is hypotenuse square is equals to perpendicular square plus base square, right? Now we will just substitute the value over here. Are we having the hypotenuse? No. So we will say that OM square. What is perpendicular? That is ON square. And what is base? That is MN square. Now let us substitute the values over here. What is OM? OM we need to just calculate, right? So let us return be as like OM square only. Now what is ON? It is basically having a side that is 8. And here we are having as a 7. Right? If I just solve it further, so here we will be getting that is OM square is equals to, what is the square of 8? That is 64. And square of 7, that is 49. If we just add it and solve it further, so here we will be getting that is OM square is equals to, solve it here like 64 plus 49. So 9 plus 4, that is 10, 11, 12, 13, 1 carry, and 6 plus 4, 10, 11. So we have got like 130. And if you know that, we just shift the square both that side, it becomes root. So we have got our perpendicular distance as under root or square root 130 unit. So always just try to keep this in the bracket because it's a major thing that we have to calculate, right? Now, we have been got like hypotenuse we are having under root 113. Perpendicular we had like 8 and base we had like 7. So these all the 3 sides we are having of a right angle triangle, hypotenuse, perpendicular, base. And what was the question that we need to just calculate? The question that we need sine theta and cos theta. So first of all, let's have the trigonometric ratio. Sine theta is perpendicular upon hypotenuse. So what is perpendicular? 8. What is hypotenuse over here? That is under root 113, right? And if we just move further, we need to just calculate the cos theta as well. So cos theta is what? Base upon hypotenuse. What is base? That is 7. And what is hypotenuse? That is 117. Sorry, 113. 113 we have got, right? Now, we will just substitute the value of all this trigonometric ratio in the given question. The question was like 1 plus sine theta 1 minus sine theta upon or by 1 plus cos theta 1 minus cos theta, right? Now, if we solve it further, as you can see that this is written as a plus b, a minus b. So as we know the identity, what is that? Since a plus b and a minus b is equals to what? That is a square minus b square. This is the algebraic identity that we have discussed in the previous class, right? So it will become 1 square minus sine theta square. And same also here in the de denominator part. It will also become 1 square minus cos square, right? So now, if we just substitute the value over here, 1 square will be 1. Sine theta is value what? That is 8 upon under root 113 square. Now, if we just move it further, it will become 1 minus 7 upon under root 113 whole square. Now, if we just move it and solve it further, so we will be getting a step like, if we just do the square of like root x into root x, that is equals to root x square. So it is always x, right? Because root get cancelled and the power are added in exponent format form. So here we will be getting like 113 minus 64 upon 113 whole divided by 113 minus 49 upon 113, right? If we just move further, so we will be getting like 113 minus 64 upon 113. And if I just do the reciprocal of this, it will become 113. That is 113 minus 49. So here this will be cancelled, like 113 and 113 will be cancelled. And if I just do the subtraction, 113 minus 64, so you will be getting the answer, right? If you just say all about the 30, so it will be 9 over here, and here it will be 10, right? Just everyone just do the subtraction. So 9, like 10, 11, 12, 13, right? Here we have got as 10, so it will be 49, right? And if we just solve this with 49, so it will be what? 464. So here we have got it as like 49 upon 64. That is our final answer. Is that clear to each and everyone? This is your final answer for the first question. But now we are having one more question for that as well. The second question that is cot square theta. So what is the meaning of cot, or what is the formula for trigonometric ratio for cot? We know that cot theta is equals to base upon perpendicular. What was our base? So if we just check in the right angle triangle, base we are having 7 and perpendicular was 8, right? So base was 7 and perpendicular was 8, right? But here the question says that it is square. So it will be cot square theta. So it can be written like cot theta whole square, right? If we just put or substitute the value of cot in this one, so you will be getting like 7 upon 8. If we just do the square of this, you will be getting 49 upon 64. So this is your final answer. These are the question type 4 for the trigonometric ratio. We need to just substitute the value and evaluate each and everything, right? I hope it is very clear to each and everyone. Now, let us move with the trigonometric function for the different angles of any size, how we can just substitute the value and calculate the different types of angle over there, right? Okay, so now let's start with the next thing, that is trigonometric angles with the different measures, right? So for that, let us consider a triangle and discuss like how the angles have been calculated, how we just calculate them. So let's take for a special case we are having, like let's have a special case, how we can just calculate the values of angle, right? Okay, so if we just move it further, let us have an triangle. Let us suppose this is our triangle, okay? 1 minute. Okay, so this is your triangle, and let's suppose I have just make a perpendicular over here. Now, here you can see that, let us suppose this is an equilateral triangle A, B, C, and this point is D. And I say that equilateral triangles means all the sides are equal. So let's suppose it is 2 centimeter, this side also 2 centimeter, and this whole, the path of AB, we can say that it is 2 centimeter. But if I just make a perpendicular, so it will become from here to here, it will be now 1 centimeter. And from here to here, it also will become 1 centimeter, right? Now, it is making a right angle triangle. So here we can see that 2 right angle triangles are made, like 1 and this is 2. Now, let us suppose that this angle which is made, it is having an angle of 60 degree, right? And here we are having an angle of 30 degree, okay? Now, if we can calculate the value of BC, because we are not aware of the value that what is the value of BC, right? So what we will do, as we know that triangle ABC is an equilateral triangle with the two sides, like all the three sides are equal. That's having a measurement of 2 centimeter, right? And here we can say that AD is a line of symmetry. AD is a line of symmetry, right? Okay. So now here you can see that it is a line of symmetry. So now if we just apply Pythagoras theorem is like triangle ABC. As we know, what is the Pythagoras theorem? It is hypotenuse square is equals to perpendicular square plus base square, right? So now if we just substitute the value, what is the hypotenuse over here? That is AC. What is perpendicular? That is CD. And what is base? That is AD, right? So if we just see that here, so value of AC is 2 centimeters, and we will substitute over here. We need to just calculate for CD, and AD we are having as 1 centimeter. Why? Because here the line AD is a line of symmetry which divides equilateral triangle to two parts, two right angles, right? So now here you can see that 2 square is 4. CD we need to just calculate, and here 1 square will be 1 only, right? Now if we just move it further, so here 4 minus 1 is equals to CD square. So 4 minus 1 is 3, that is CD square. And if we know that, we just move the square to the next part, so it will become like CD, it will be having root 3 here. Or you can having the unit like centimeter. Here we have got the value as root 3. Now, let's suppose I am talking about the trigonometric ratio, that is sine. And if I say that we are taking the reference angle at 60 degree, the value will be like perpendicular upon hypotenuse. So what is the perpendicular we are having over here? So it is root 3, and hypotenuse was, that is 2. So here we have just got the value of angle. Can you see here? We have got the value of sine 60 degree. That is root 3 by 2. So this is the way how we just calculate all the trigonometric angles of the given like ratios like sine, cos, tan, sec, cosec, cot. All the trigonometric ratios angles have been calculated like this, right? So if I just move further, and I can calculate all the trigonometric values angles, right? So let us discuss that and make a table for that, because with the table and the formation, then only we will be able to solve each and every thing. So let's have a table for that. So let's construct a table so that we will have a proper valuation, and we can just substitute the value and just we can calculate each one, right? So for that, you have to do the partition. Like suppose this is our angle. So we will just make the 6 partition like 1. Here it will be 2. Just take as here like 1 minute. So 3, 4, and here it will be 5. So we need to just have 6 partition, right? So I think we have got that 1, 2, 3, 4, 5, 6. Now let us calculate the angles over here. So before that, we need to just substitute the value. We are just calculating for all the angles. Like the first will be 0 degree. Here we will be having 30 degree, 45 degree, 60 degree, till 90 degree, right? And we will write here the trigonometric ratios. Here we are just taking the reference angle as A. So it will be sine A, cos A, tan A, and here it will be cosec A. Here it will be sec A, and the last, not the least, that is cot A, right? Now we will just write the values for that. As we have calculated, the sine 0 is 0, sine 30 is 1 upon 2, sine 45 is 1 upon root 2, sine 60 now only I have calculated, that is root 3 by 2, as you can see over here, and sine 90 is 1. Now we will just make the reverse of this. Always remember, here first we need to just keep in mind all about the sine angles. Now we will just repeat the same values, just we will reverse each and everything. Now here, as you can see, the first number was 1, so it will be here 1. The second number was root 3 upon 2, so it will be here. It will be repeated in a reverse direction, right? Now, as I just told you, what is tan theta, that is sine theta upon cos theta. So now I am taking for, we will just divide it. Like 0 upon 1 is what? It is 0. Here we will just divide it. So 1 upon 2 by root 3 by 2, it will be what? It is 1 upon root 3. And if I just do for this same, let's do the division part for this, you will be getting all the values. Here you will be getting that is root 3. But can you tell me what is 1 upon 0? It is not defined, my dear students. So it will be not defined. Now, as we all know that, what is a reciprocal of, or what is a reciprocal of sine? That is cosec. Now we will just reverse the form, right? So if we just see that reciprocal of sine is cosec, like 0 upon 1, that is not defined, right? 1 reciprocal is 1 upon 1 by 2, it will be only 2, right? So it will be 2 here, it will be root 2, it will be 2 upon root 3, and here it will be 1. Now, if we just move further, what is the reciprocal of cos? That is sec. So we will just do the same thing. It will be 1, 2 upon root 3, root 2, and here it will be 2, and here it will be not defined, right? Now, what is the reciprocal for tan? It is basically cot. So it will be just like that only. So it will be not defined at 0 degree. Here at 30 degree, it will be root 3. Here it will be 1. Here it will be 1 by root 3. And here it will be 0. So these all are the trigonometric angles that we are having for the all trigonometric issue like sine, cos, tan, cosec, sec, cot, right? These all are the values. And now we will be using these values to solve the given question, right? So I hope it is very clear to each and everyone how we just calculate each and everything. So let us solve one question based on this concept that will be more feasible to understand, right? So if I just take a question for that, let us suppose I take like sine 60 degree, cos 30 degree, plus sine 30 degree, and here we are having like cos 60 degree. To solve this question, we should have a proper reference of this table. We will just always make a reminder of that. We need to just write the sine first and you will be getting all over the values, right? So we need to just calculate for sine 60. Now only we have calculated sine 60 is what? Like root 3 upon 2. Something is there? No, it is product, like you have to multiply. Cos 30. Cos 30 will be root 3 by 2. You can just see here, right? What is sine 30? Sine 30 is 1 by 2. So you have to just see the reference table when you are solving, or you have to just keep in mind and calculate, because in examination you will not be able to have this chart, right? And what is cos 60 degree? So you just take the table, that is 1 by 2, right? So if we just do the product of this, you will be getting the values. So here, if you just see that, it will be 3 by 4 plus 1 by 4. And if you just do the LCM for this, LCM of 4 and 4 is 4 only. We need to just add the two like fractions. So it will be 4 and it will be like 3 plus 1. That will be 4 by 4. So the final answer that we have got as 1. So now I hope you have all understood all about like how we can just substitute the value of trigonometric angles in the given question and how we can calculate the answers, right? So everyone just make sure that you all have understood it. And if you're having any doubt, you can just ask me, right? And we will discuss many more questions based on this and Olympiad and advanced level of questions in the live session. So everybody just make sure that you all understood this, make a revision of this, and we will meet in the next class to solve different level of problems in the live session. So I hope you all enjoyed it, learned a lot, and practice more, practice hard. Okay, now let's meet in the next class. That is your next live session. Till then, see you. Bye-bye. Take care. Bye, everyone. Thank you for joining class.